Good day, everyone. Thank you for joining today's Docker webinar, Secure Kubernetes from Dev to Prod. A couple housekeeping items before we get started. Please note this session is being recorded, and a copy of the recording will be sent out to you a couple days after the webinar. We will be taking questions at the end of the session, so please type them in the Q&A window located in the lower right of your screen, and our speakers will address them at the end of the session. I would like to now introduce our speakers, Jenny Fong, Director of Product Marketing, and David Yu, Partner Solutions Engineer. I will now turn things over to you, Jenny.
Thanks, Melanie. Good day, everybody. Thank you for joining us for this webinar, and we're excited to share how Docker is delivering secure Kubernetes from Dev to Prod. Give me a second while I share my screen, and I'll get this going. Okay, so on the heels of our announcement at DockerCon Europe, we're very excited to share Docker Enterprise Edition 2.0, which was released to beta 3 weeks ago. So this next release of Docker EE, or Docker Enterprise Edition, as we call it, integrates Kubernetes for container orchestration running side by side with Docker Swarm. And so this really means that two of the biggest names in containers are joining forces. So you may know Docker as the company driving the container movement. Docker EE is the only container platform to address containers for both legacy and new apps across Windows, various Linux distributions, and even Linux on mainframe, and across both on-prem and the cloud. So with Docker EE, you have an enterprise-ready container platform that gives you the broadest selection of apps and infrastructures to work with, and now it will also give you the choice in orchestration tools. Now, if you're new to the space, you may think that Docker EE is an orchestration solution, but it's much more than that. So it's a way to manage images, containers, clusters, policies, and users in a secure enterprise-ready manner. And one key aspect of the container platform is the registry solution. So you can deploy containers with Kubernetes, but the containers rely on images that have to be managed and secured. And Docker EE does that through our Docker Trusted Registry that provides a private registry solution that has many security features that we're going to talk about today. I'm not saying that orchestration isn't an important part of the solution. It definitely is. It's in charge of the deployment and the placement of the containers in the cluster. And what we're doing here is giving you the option of what orchestrator you use when you are ready to deploy the app, not when you build the cluster. So how is that possible? It's because when you build a Docker EE cluster with this next release, and you can try it yourself with the beta, there are managers and workers. Now, each manager is designed to be both a Swarm manager and a Kubernetes master, while each worker can operate with either Swarm or Kubernetes APIs. That means each Docker worker comes with kubectl and kubeproxy, as well as everything it needs to be a Docker worker. So you don't have to worry about the orchestrator choice when you're initially building the cluster. You can determine it when you're ready to deploy the app, which orchestrator to use. But the key here is offering both orchestrator choices under the same umbrella, so under the same management plane. So you can manage all of your users and the images and how images progress and get deployed into production. And that's what we're going to talk about today. But just to close out, since we just launched the beta 3 weeks ago, I wanted to promote that you can sign up for it for yourself, and we have actually 2 different ways for you to get your hands on the next release. So we have a hosted beta option, which is great if you don't have the time or the space to install and configure your own EE. You just go to this link here, which is the goto.docker.com/EE beta PWD. PWD stands for Play with Docker. That's a tool that we offer to help customers learn about Docker, and we have this site that is based on the same back engine of PWD. The second and more, traditional way is you can sign up at beta.docker.com to get access to download and install the software. So we'll continue to talk about this next release, but definitely encourage everyone to go out and try it for themselves. So let's talk about how we can help secure your Kubernetes deployments from dev to prod. I use that term because, you know, typically in an enterprise environment, you have developers that are working on code on their laptops. They're checking in, checking out code. They're building Docker files and they're building Docker images. But there's a lot that happens from that point to when that image is finally deployed into production. And so there's a lot of different steps that have to happen from developer to production, and we're going to talk about that. And how we're going to talk about that is to use an analogy that many of you are familiar with, which is a supply chain. So let's think about, you know, buying some furniture. There's a lot of things that have to happen between the raw materials that get sent to a factory, the factory that builds the piece of furniture, and then the furniture gets sent to the store, and then finally to you. So that is a supply chain from the source of the materials all the way to the consumer. Similarly, there is something called the software supply chain, which is the code that goes from a developer's laptop through testing, staging, and QA, and all of those other steps until it's run in production. And in this case, with Docker EE 2.0, running in production can be deployed through Swarm or Kubernetes. So one of the things that we're going to talk about is how Docker EE secures that entire software supply chain even prior to when you're ready to deploy the app. So there's, again, highlighting all those different steps of what you need to do to ensure the images are who they are, you are authenticated by who created them, that you know that the image itself is clear of vulnerabilities and is ready to be staged in production. And so how we'll go through that is summarize some of the things on this slide. So secure image management, secure automation, and then flexible granular RBAC. So let's go ahead and get started with secure image management. One of the key aspects of running containers is knowing what's in it. And so one of the capabilities of Docker EE is image security scanning. This is a binary level scan of an image to look for and checking it against a NIST CVE database. So it's basically looking at every layer that you're including in your image file, comparing it to the CVE database to see if there is anything that needs to be patched or updated. This is done within our EE portal, so you get a readout of what is a critical vulnerability versus maybe a minor vulnerability, allowing you to understand what's inside your containers. But once an image is scanned, it is also stored in terms of the information so that if a net new vulnerability comes down the stream, it'll alert you to the containers that have already been scanned that have that particular signature. So it'll let you know when new vulnerabilities come in and lets you take corrective action on that. So knowing what's inside your apps is important, as is how the images themselves move from repository to repository. So in a large organization, you will likely have several different folders or several different repositories for different teams and for different projects. Now, one of the things that happens as you're moving along that software development lifecycle, so you're moving from development to test to QA to staging, is you will need to move the images themselves from repository to repository. That's all fine when doing it manually until you get to a certain scale where that becomes very difficult. We know of customers that are managing 9,000 and above different images, and you're not going to do that manually. So one of the capabilities within EE is image promotions, which is a concept of setting some rules around when an image can be promoted from one repository to another. So this helps to automate image management, remove those manual bottlenecks, And then also it helps to enforce policies. So if I combine the first feature of security scanning with image promotions, I can create a policy that helps to drive what I want the behaviors to be in my organization. So in this example, a developer has access to a dev folder for their project, their Hello World project. We can set up a policy as the administrators of this environment that anything that gets a certain tag, like latest, and has been scanned with no critical or major vulnerabilities will be automatically promoted into the next folder, which is the QA folder. There's a couple of benefits in setting up a policy like this. One is that, again, you get to automate the movement of images at scale. So think of this as, this is one developer with one folder, but when you grow into hundreds of developers with hundreds of folders, setting up some of these rules will help to control what makes it to the QA folder. Another part of this is by creating this repository policy, you're enforcing the security scanning practices. So you're telling the developer, hey, I'm not going to QA your code until you've cleared it from major and critical vulnerabilities. So it's a way of enforcing a practice around security scanning. Of course, this also helps to ensure that nothing has a vulnerability when I'm ready to deploy them in production. And the last part of this is by enforcing the policy, I only have to give my developer access to the dev folder. I don't have to give them access into the QA folder. So as a QA team member, I minimize my exposure of who has access to that QA folder. So somebody who doesn't have permissions can't go in and change tags or do something malicious because I've separated the control and access to the right number of people. So think of this in the terms of a Kubernetes deployment where the developer team is working on the code. They can check in and check out images only to their particular repository. The policies themselves allow the images to progress along that life cycle or that supply chain. And then finally, when it's ready to go to production, only the right people have that ability to push it to production. That's an important concept, and as we talk about moving things through stages, there's another key capability within Docker that is valuable for securing the workload, and that is Docker Content Trust or image signing. So when we talk about image signing, we're looking at how a developer can add their own private cryptographic keys to an image. So they're basically adding a signature, which is a way to have this proof of origin or provenance that this image came from an approved developer. So this is a way to put a stamp on an image that is, cryptographically encoded into it, and then when it's time to deploy, you can actually check against those signatures. So it's a way to ensure trusted content across that life cycle. So here's a deeper example. Many companies today are integrating their CI tools with Docker Enterprise Edition. Just recently we did a webinar about integrating GitLab, and we showed a demo of that. So one of the things you can do is actually give your CI tool the ability to digitally sign an image as it goes through that workflow. So in this case, the icon there is Jenkins, but it can be any CI tool. So what is happening is as the image has completed the CI workflow, it gets digitally signed to say, hey, this came in as a valid CI workflow. As a policy, you can decide to have a security scan on that. The scan itself, completion of the scan can be a second signature, so a second signature can be added to the same image. And then when that passes into the staging repository and the team that is responsible for the staging environment, they also have the ability to add their own signature to say, yes, we've reviewed this workload in staging, it's working, and it's now ready for production. The key to making this all work is that in Docker EE, there is a capability to prevent unsigned images from being deployed. So when it's ready to go in production, we can have this check that says, do I have the CI signature? Do I have the security scanning signature? And do I have the staging signature? If I have all three, then I will allow this image to be deployed in production. But if I don't see one, if one of the stages is missing, meaning somebody has like coverted the process, then I won't allow that image to be run in production. So again, not just the scanning and the results of the scanning, but making sure that all the stages of the process of software development have been checked off before I run this in production. Part of this is we've talked about is as we move the image across different teams is how we separate those concerns. And so how do we make sure that only the right people have access to production, only the right people have access to QA, and only the right people have access to dev? And that's through the role-based access controls. So Docker EE has very granular and flexible access control permissions that you can set. That can be actually integrated with your corporate LDAP or Active Directory. The way it's done is an administrator creates grants to certain Kubernetes namespaces, giving certain teams access to specific namespaces. The additional capability that is unique to Docker is that we extend role-based access control to nodes. So we have the ability to separate different nodes in the same EE cluster for different teams as well as for different orchestrators. So think of it as if you're in a large organization, maybe you have teams that have already started down the path with Swarm, maybe you have teams that are started down the path with Windows and Docker, also using Swarm, and maybe you have teams that are using Kubernetes. With role-based access control, I can divide my 6 nodes, my 6 worker nodes here in the sketch to be only used by those specific teams. So I can decide this team, the .NET dev team, only has access to deploy to the first 2 nodes, while the Java team using Swarm has access to the next 2, and the Java team using Kubernetes has the last 2. So I can set this up through role-based access control. When those individuals sign into the Docker EE environment, they will only be able to deploy to those 2 and really sometimes only see the nodes that they have access to, depending on the rights that they have. And the permissions carry throughout the Docker EE environment from the control plane as well as through trusted registry. So you integrate your LDAP and Active Directory once, set the permissions once, and they apply across both environments. So with that, I walked through a couple of the key capabilities of how we bring security to the Kubernetes application. What I want to do is now hand things over to David to show you what that looks like in a real Docker environment. And let me stop sharing.
Great. Hey everyone, this is David Yu, and I'm going to walk you guys through the Enterprise Edition and how it relates to Kubernetes and the security features we're trying to show you that can be enabled through Docker Enterprise Edition. So a really quick intro again to the Docker Enterprise Edition platform. The underlying engine that we provide in the platform is the Enterprise Edition engine, and we actually join those engines as part of a cluster that's managed by the Universal Control Plane. This is a actual cluster that I have here it's only 4 nodes, where you can see one of the nodes dedicated to be a Kubernetes worker. We also have a Swarm worker that's running our registry, and we have another one that's just also available so we can run Swarm workloads as well. So you can see there's a lot of different types of orchestrations we can do, and we can centrally manage that in the single control plane. In addition to just the management interface, we also provide a registry called the Docker Trust Registry. And so really that means like you can actually see images that you're able to distribute across your teams. What that allows you to do is it allows you to support the images themselves from a authorization perspective, and then also it allows you to go deep into the image and see what's vulnerable within that image layer to actually go ahead and remediate any issues that occur before they get promoted to production. What I'm going to do is I'm going to go and walk through a really quick demo of the Kubernetes concepts, and then I'll transition over to the registry to actually show you how some of those secure supply chain concepts roll into play. But here I have basically my Kubernetes environment set up as part of the cluster, and then what I can do is I'm going to go and take a look at what we have here today in terms of our role-based access control setup. So at the very top level inside of the Enterprise Edition, you can actually specify what's called an organization. Think of an organization as maybe perhaps a line of business within a group or a company, or it could be an actual entity that supports a specific organization. And so within this organization, I actually have two different types of teams. There's an ops team and a devs team. And what I'll do is actually we'll utilize two users. One of the users is an ops user called Chad. The other user is a dev user called David. And so what we can do is we'll see how this actually comes out. But we'll actually see how role-based access control is utilized to deploy and secure Kubernetes workloads. One of the concepts you'll learn with the Enterprise Edition is, so this all organization teams are basically the structure, and you can sync that with LDAP and Active Directory. But in addition to that, you want to create what's called a role. So a role really describes basically at a granular level what types of operations a specific type of user can actually perform. In the terms of Kubernetes workloads, you'll have multiple types of operations that you can do. And you'll notice there's actually a very granular way of defining what specific users can and can't do. For example, if you were to just allow people to deploy specific Kubernetes workloads, there's this Kubernetes operations deployment specification or set of permissions that you can enable, and then you can also do things such as, making sure that namespaces can be updated, created, or deleted for specific users. Now, for this demo, I've actually created a role. The role is called kubedeploy, and so I actually created a role that defines multiple deployment operations that you can do. And what I see here is I actually have the ability to get, list, and update the namespace, and then create a replication controller, and also do some pod operations. And so what I'm going to do is I'm actually going to go ahead and apply this role with this specific organization, which is ops, to an Nginx namespace that I'll create. So inside of the UI, you can actually go ahead and create namespaces very simply. So you can always do this through kubectl, which is one option. The other option is directly inside of the UI for EE 2.0. And what I'll do is I'll actually go ahead and just copy and paste a specific example for creating a namespace. And so this is basically a namespace that's really simple. It's just going to house our Nginx pods and deployment. And so I'll just go ahead and copy this in here, create this specific namespace, and voila, I've got a namespace. Now, I'll use that namespace to basically grant the operations team access to deploy pods onto that namespace. So what I'll do is I'll go ahead and create a grant. And this gives you a walkthrough of some of the ways you can apply permissions to specific roles and specific sets of people. So there's three different parties involved. One is a resource set, which is what are we applying it to. In Swarm, there's basically a concept called collections that houses Swarm resources. In Kubernetes, it's going to be namespaces. So I'm going to select the Nginx namespace. And then as far as roles, we already created a role. I'm going to use the kubedeploy role. And so what I want to do is allows somebody that's part of the Acme Ops team the ability to utilize that role on that specific namespace. And I'll go ahead and create that. So, Chad is part of the actual. He's part of the actual ops team, and if I log in as Chad, this is his view of the cluster, a little different, and he doesn't have anything deployed yet. But what I'm going to do is I'm going to show you a different way of deploying things through the CTL interface that basically allows you to interact with the Kubernetes cluster. Cool. So if I go ahead and do something like kubectl, get pods, what I've done already, just so you know, is I went to my ECP bundle that I downloaded for Chad, and I sourced this, basically the script that allows me to now talk to my cluster. And so if I do something like kubectl and get namespaces, kubectl, get pods, can't define pods because of my role, but you should be able to run specific operations that allow you to basically do certain things. I've limited Chad's permissions, so I'm not going to show you some of the other kubectl commands, but what I'll do is now switch over to a directory where I have a specific workload I want to deploy. And Nginx RBAC. So if I just show you, Nginx RBAC is basically a deployment, and actually inside of the metadata of that deployment, I'm actually specifying the Nginx namespace. And I'm going to deploy 2 replicas, which is basically 2 pods with Nginx with specific specifications. So I run kubectl as Chad, and then I go and say Nginx RBAC. Chad has basically created an Nginx deployment, and you should see that here. And then you can see here, this is basically my my pods. So I can see I just created them right now, and they're running as of now. David, on the other hand, is not part of Chad's team. He's actually part of the dev team, and so if I were to log in as David, you will not see even the namespace. So if he goes to the kubectl namespaces and tries to switch or define any namespace, he can't do that. Doesn't have any namespaces that he has access to yet, and you won't even see the pods that Chad has deployed. So really cool way of basically isolating, creating what's essentially a virtual cluster, if you will, using namespaces, and allowing to do that with RBAC using the enterprise edition roles, grants, and permissions that we define inside of the platform. Now, what I want to do is show you another demo utilizing what's called node-based isolation that Jenny described on a Kubernetes workload. This is all available. The steps I'm doing are all available through the documentation. But what I've done already is I've actually created a namespace called ops nodes, and I've actually gone ahead and granted full control to that namespace to the ops team that I created. And then the other thing that I did was you can actually take a namespace, and you can also tie it to basically what's called a collection. And so if I go into my my administrator account and I log in and see, these are my namespaces. Ops nodes is actually tied to what's called a prod nodes collection. Inside, what that really means is I actually created a collection just for nodes to deploy. And if I go to my nodes here, each one of these nodes has a collection that it's assigned to. The one that I created called prod is actually assigned to worker node 2. The other ones don't have prod, they're all in shared system. So if I were to deploy any workload to the ops node namespace, then I should only see that actually run on worker node 2, right? That's really what I want to see, and I'm going to show you how that's actually done. So I switched my namespace to ops node so I can see here. I should not have anything running already. I have a token. I'll go ahead and delete that for now. And I'm going to go ahead and start to actually deploy something to that ops node namespace. And so what I'll do is now show you my Nginx RBAC nodes. This is my other. So this is my basically my other kube YAML file here. And what I'm doing is, instead of a deployment, I'm actually going to deploy what's called a replication controller. Replication controller in the Kubernetes world means this is a way to deploy a set of pods and always set a desired state of the number of pods that we should run. And so in this case, we're just running one, but I'm going to actually run it on the ops node namespace. And you'll notice that after I deploy it, the pods that are part of that specific deployment or that replication controller will show up inside of worker node 2. So again, I'm actually part of kubectl. I create the actual YAML file, and we created that replication controller called Nginx. Still on the ops node namespace inside the UI. And then if I go here, I should see the servers created. I should also see pods also show up. Let me see if I can switch back my namespace to ops nodes. That's how I can see it. Here we go. We got the replication controller. We also have the pod that actually is running. And then the way you can actually check where it's running is if you click on the pod, you'll notice there's going to be what's called a node. It should show up here, and we see that it's actually running on worker node 2. And so really what that means, like if you were just to kind of translate this to English, is what we can actually do is we can actually specify based upon permissions where those pods will actually fall into. Based on your default permissions, like let's say you were a specific ops user and you were to deploy something onto your namespace or your virtual cluster, if you will, we will always guarantee that those pods will fall into the actual nodes that you're given privileges to deploy onto. So it's a really powerful feature, right? Allows you to basically isolate workloads to nodes. The final thing I want to show you is really something related to the secure pipeline. So we talked about the registry, and we actually have the ability to store and scan and also sign images with the capabilities of Docker and Docker Trusted Registry. So I want to show you a really quick example of how we can do that. So I'm going to show you an example of pulling an image from Docker Store, and then I'm going to tag it, and then I'm going to sign it, and then push it to my registry. So what I'm going to do is first pull Nginx latest onto my actual. I'm going to do this onto my actual my laptop. So I'm pulling Nginx. Should already have it. So we have Nginx already built in. Next, what I'm going to do is just basically create a tag. I'm going to use Nginx 2, because I already have one. And I'm going to log into my registry, which I have running up. Let's see here. And then what I'll do is then basically there's a way to say you want to sign an image. And once you export this flag, any specific Docker commands for Docker pull, push, run is going to leverage the signature that you have built in. And what I'm going to do is now push this image that I just created, this tag, to my registry. And what should happen is it's actually going to sign. That image and then push it to this repository. And so what I can see here is this is the actual image that I just pushed as of today. And it's actually already scanned the layer that I previously had. And what I can do is I can see here inside of the actual image what's vulnerable. So in this case, the latest Nginx image already has some vulnerabilities built in. And so you can see this is the file path of inside the image where it resides. And we can click on the actual CVE to learn more about the actual vulnerability. So these are basically inside the Nginx image are basically libraries that need to be updated, and you can actually manually do so. But what that Nginx built that's on Docker store is a little out of date. So you should be able to also build your own image, right? That has Nginx yourself with the more latest versions of these libraries. That was scanning and signing in a nutshell. Now, the other thing that we have that ties in a lot of the pipeline concepts inside the actual universal control plane is a feature that allows you to basically run only signed images. So what I didn't show you, but what you can do is you can actually go ahead and sign images using your client bundle. Your client bundle comes with a private key that you use to import that into your Docker notary tool, which allows you to sign images. And what I can do is I can actually say, we want to only run signed images that are signed by a specific team. And so you can add, you can even add more teams if you want. Maybe it's both dev and ops. And in order for the image to run, in this case, it needs to be signed by both ops and dev from the active organization for it to actually run as part of the cluster. I could quickly validate that this works by actually going into the images section here and just trying to run a pull command, right? If I wanted to pull, let's say, Redis, for example. What should happen is we should get an error saying it didn't meet the signed policies, so we cannot actually pull it because the signature that we have from that specific Redis image does not meet that criteria that I just went ahead and specified inside the cluster. So hopefully that gives you an idea of how a lot of these concepts in terms of secure supply chain, securing role-based access control for nodes and deployments and Kubernetes workloads actually come into practice. This is a very comprehensive platform, right? And it allows you to not only just manage Kubernetes workloads, but also your Swarm workloads, which even today there are lots of people using. So hopefully you learn a couple things. I'm going to end the demo and hand it over back to Jenny so she can continue with the presentation.
Thanks, David. I'm just going to wrap up our session today. Let me actually share my screen again. So what you've seen here is that we are able to secure both Swarm and Kubernetes in the next release of Docker EE. It's 100% interoperable with ability to run these workloads side by side. Swarm is not going away. Swarm is still important for a lot of our existing customers and our ecosystem partners. We have the RBAC and RBAC for nodes to allow you to have that multi-tenancy where each team gets their own resources, isolation from each other. The single dashboard to view both your Swarm and Kubernetes deployments. And actually, one of the things that we want to remind people is also, today Docker is the engine behind Windows containers, and while there is Kubernetes support for Windows in beta release, today the Swarm and Windows is in production with Docker. Another quick reminder to sign up for the beta so you can get your hands on this. And again, if you don't have the time or the capacity for installing your own beta bits, you can always go to docker.com, or sorry, go to docker.com /EEBeta-PWD. That gives you access to an instant environment in a hosted environment. So you have full access to UCP as well as DTR, but you don't have to install it yourself. Lastly, if you're really just getting started and just want to start playing around and learning Docker and learn Kubernetes, we also have new releases of Docker for Mac and Docker for Windows Desktop that support Kubernetes. Both of these are on the Edge channel, so these are not the stable releases, but the Edge releases. They allow you to start playing with this stuff on your own laptop. They're free downloads and a great way to just start getting familiar with containers and container orchestration. And with that, that's the end of our webinar. There's a couple of questions that came in that we will answer now. And let me stop sharing so we can see the questions. There's a couple of questions around availability. So yes, we're in a public beta period right now. That will continue until we're ready to GA. We consider what we have feature complete, so GA is fairly soon. The feedback we get are just to improve and make sure that we have a production-ready deployment of the release. Let's see. There was another one that I wanted to address. There was a question about what happens to Docker Swarm. As I showed and as David demoed, Swarm doesn't go away, and Swarm's still there. You can still deploy to Swarm. And in fact, we know a lot of customers who just are getting started with containers who are still leveraging Swarm. It's a fast on-ramp, and it's a little bit of an easier onboarding experience for a lot of customers. So both of them still are available, and in fact, as we talked about, every node is ready to operate as either Swarm or Kubernetes at deployment time. Anything else you wanted to address?
There was a question around Docker orchestration and management. We do have a couple of webinars that we've done in the past that cover orchestration in a nutshell with Kubernetes as well as Swarm. I definitely encourage you to take a look at our YouTube channel. We have reporting to that available. In terms of security features, working with private Docker registries, that is essentially what the Docker Trusted Registry is a secure private Docker registry. And it has enterprise features built in that you can leverage to help secure those workloads. Go ahead.
There's a question around the Kubernetes versions we use. So this next release will be conformant to Kubernetes 1.8. If you're familiar with Kubernetes conformance, they require that you are tested against either the most recent release or one back. So this particular release of EE goes to the most recent stable release, which is 1.8. And for our next update or next release, then we would move to the next form version. But the main thing is we do intend to stay conformant to Kubernetes. That means that we pass their tests around full API compatibility.
What is there in Kubernetes which is not in Swarm? I'd say very little, to be quite honest. We have a lot of the features in Swarm that's already in Kubernetes. I think it really comes down to more of a religious debate on where they want to deploy their workloads with which orchestration management solution. Kubernetes is, I would say, from the operations mindset, and then Swarm is coming from the developer's mindset of simplicity. You'll notice Kubernetes is actually more complicated to deploy workloads because It's coming from a different mindset of actually managing workloads as opposed to actually simply deploying them quickly and easily. DTR in terms of HA, we do have highly available DTR HA deployments that are possible through the registry. And we also have the ability to store those images, right, to a specific storage bucket. A lot of people use S3 or they use some of the Azure Blob Storage or even NFS to actually provide backend storage to the registry. If you're thinking about migrating your Swarm containers over to Kubernetes, luckily we have a tool built into the Enterprise Edition that allows you to deploy Kubernetes workloads straight from a Docker Compose file, and that's built into the Enterprise Edition UI. And Swarm and Kubernetes, they're different orchestration solutions. I would say they're not 100% equal, but they're coming from different mindsets. We do try to, from a Docker perspective, also try to build features that actually reconcile the two. But yeah, it's a religious debate. I would say if you're thinking of actually working with orchestration for the first time and you don't want to deal with the complexities, I'd highly recommend using Swarm. If your organization already uses Kubernetes and is already sold on it, they can also use Kubernetes. The beauty of this is this allows you to pick and choose whatever you want, and we have the solution to support both orchestration solutions.
I also wanted to touch on something that is part of this release around DTR. We didn't go into some of the new features of DTR here, but on making sure that you have a highly available solution or a resilient solution, there's a new capability called image mirroring, and you can leverage that to mirror your images to something like Docker Hub. So that could be a good backup solution for making sure that you have off-site or cloud-based, recovery for your images. And we'll talk about a lot of these in more detail as time goes on. There's a couple of interesting DTR capabilities that are being released with this 2.0. And I think that is all of our questions. So thank you guys for joining us today. Melanie, did you want to close?
Yep, great. Thank you, Jenny. Thank you, David. This does conclude the webinar. And as a reminder, this session was recorded, and a copy will be sent out to you in a few days. Also, please make sure to check out events.docker.com to see a listing of our upcoming events. Thank you again for joining us, and have a great day.